Hello all. Public key cryptography. Last video, we examined what is public key cryptography and how it differs from private key cryptography. Now, in this video, let us see what are the key facts. That is, what is the private key and public key and how to achieve authentication and secrecy by the use of public key cryptography. So first let's start with the usage of key pairs and let us see about secrecy and authentication. At the end we can discuss about how public key cryptography can be applied for various usages. In the last video itself, we discussed that in public key cryptography, each user is having a key pair. So here, each user will be given with a key pair we discussed. So KU means the public key, KR represents it is the private key. So here look at this for user A, he has two keys. This green key and the red key is the KU means KUA means public key of user A, KRA means private key of A. Similarly for user B, he has a public key and private key. User C has a public key and private key. It's a key pair. So each user is provided as a pair of keys. Now this first box is for A, user A. User A knows all the public key of all the users. And this is for user B. This is for user C and this is for D. So public means it should be available known to all. So in the user group, all other users, here for example A, B, C, D. So user A, B, C, D exists there. Public key of all the four users are known to all others. So that is what shown in this figure. But look at the private key, KRA. Private key of A is known only to A. Private key of B is known only to B. Private key of C is only known to C. So this is how the public key crypto system works. Public key should be known to all, whereas private key must be kept confidential only to the particular user. Now, let us see how the encryption happens. Here at the sender side, the receiver side. The sender side, here assume it is the sender is user A and receiver is user B. And the sender tries to convert the plain text into the ciphertext with the help of an encryption algorithm. Here what key is using? The red key is the private key of A. So he is using private key of A and he encrypts the message and sends the ciphertext to the receiver. In the receiver side, he is trying to decrypt. When it is encrypted by private key, it must be decrypted by other pair. There is the pair of other one is public. Okay, it is a pair. One should be used for encryption, the other vice versa should be used for decryption. So he private key is used in the encryption. So what key is using? Here look at this KUA. This is the public key of user A. The public key of user A is known to user B also. So B uses the public key of user A to decrypt the message. So this is how the public key crypto system works. So remember that private key is known only to the user, whereas public key is known to all other. And it is a symmetric key. Same key is not used for encryption and decryption. So one key is used for encryption, the other one is used for decryption. It may be a private key or maybe a public key. Now let us see how it ensures authentication. Now, use the same methodology where the message user A uses its own private key to encrypt the message. So, what happened? Anyone who won't having his message can be received. For example, here in this example, the user B is possessing the public key of A. So user B can decrypt the message. So here B is the intended recipient and B can decrypt. Now there is one more scenario that if I am having one more user, for example the user C, okay, user C want to apply the decrypt algorithm, he also know the key. Am I right? He is also aware of user KUA. It is a public key. He can also use the public key of A to decrypt the message, and he can also retrieve the plain text. It is possible. But what it guarantees here, it is not providing any secrecy. It doesn't mean for only for B user C, but whoever having the public key of A, whoever holding the public key of A can decrypt the message. But what it guarantees, if it is able to be decoded by the decryptor by the public key of A, it means that it is locked or encrypted by the private key of A. Who is holding the private key of A? It is only user A. So it ensures that only user A can able to generate this message. So it provides authentication. We all know that authentication term means that whether it is about to the intended source, whether the message is originated from the intended source. Yes, here there is one guarantee that the message is encrypted with the private key of A. So it ensures that anyone who is having the public key of A can access the message. But it gives one authentication to all that this message is authentically originated from the intended source A. So this is how the usage of public key provides authentication. Now let us see how this is used to provide confidentiality or otherwise secrecy. So we have to remember that confidentiality or secrecy means it is about whether the message reaches the intended recipient. We discussed about the authentication. Authentication means intended source. Secrecy or confidential means whether it reaches the intended recipient. Now let us start the same example here. Here A and B are sender and receiver. Here instead of using the private key of A, that is the sender, here sender is aware of the public key of the receiver B. So that public key of receiver B is used to encrypt the message. Message is encrypted and reaches the receiver. The receiver B, when it is encrypted using the public key, how we can access? Yes, that's right. We can only open with the help of private key of the user. So it is encrypted using public key of B. So here now we are going to use private key of user B and it is decrypted. So it clearly shows that it is can be encrypted by whoever who is holding the public key of B. But who can open it? Well, who is having the private key of B? It is only available with user B. So it shows that always this message can be opened by the intended recipient B. So this is called as secrecy. As I told you, for example, it is the same case if it is put it in the hand of other hacker or person D. D want to try to decrypt the message, but he is having only his private key. He cannot use his private key to open this. It will not work. It can be opened only with the private key of B. So it provides the confidentiality. So when you use the private key of the sender to encrypt, it provides authentication. When you use the public key of the receiver to encrypt, it provides secrecy and confidentiality. Now let us see how we are going to provide secrecy and authentication in the same step. Because we cannot demand that I need only authentication, I need only secrecy. We need to provide both authentication and confidentiality. Now take the same case of A and B. If we need both, we need to use the public key crypto system twice. That is, we need to use the two types. Now we are going to use two times encryption. So first I am going to use the private key of the sender. So I am using K or A private key of user to encrypt the message. Then again the encrypted message is encrypted again using public key of user recipient B. So first, if you're using the encryption, if this is process secrecy, encrypted using the public key provides confidentiality. So when I send the message, it is a doubly encrypted message. For unlocking, what I need? If I use the public key of B, it should be opened by the private key of the receiver. Similarly, then the second lock, second is encrypted with the private key of A. It can be opened by the public key of A. So you should not change the order because when you try to encrypt first using the public key of B, then by the private key of A, what happens in the first case? Whoever having the public key of A can open the message. So you should not forget the order. If you want to provide both secrecy and authentication, first encrypt using the private key of the sender, followed by public key of the receiver. The decryption side, so vice versa. First use the private key of the recipient to decrypt the first message, then again use the public key of the sender to decrypt and get the original message. So this is how the public key encryption system provides both secrecy and authentication that the authentication factor is missing in your private key or symmetric key encryption system. Now, let us see where we can use this public key crypto system. There are three major categories of applications. First one, to provide encryption and decryption. There is for secrecy. If you want to send a message to you, I want to send a password to you, OTP to you, like that, I need to confidentially send to you. So I can use encrypt and decrypt with the help of keypad. Second one, authentication. It's like a digital signature. If bank is giving me a voucher, or someone is giving a receipt like that. So it should be authenticated signed. For example, if your mark sheets, it's like a digital signature. Who is there is an authenticated one who is providing a signature to you all, verifying that. So it verifies the authenticity of the message. Last one, key exchange of the session keys. We already discussed about the secret keys, like your private key crypto system. The major question about your using your symmetric key is how to share the secret key among the sender and receiver alone in a secure way. That is possible of using the public key crypto system for key exchanging. The one thing is all algorithms is not suitable for all kind of users. Some are specific to some applications. Because this you take the most prominent and widespread application is methodology is RSA. It's the best example of public key crypto system. This RSA is suitable for encryption and decryption and providing digital signature and also for key exchange similar to the LTP cryptography, whereas the Diffie-Hellman is only used for key exchange, whereas the DSS standard is only used for providing digital signature. So these are the major types of public key crypto system and its application. Let us see about the RSA algorithm in the upcoming video. Thank you.